Alright, we're on block 6 and topic 7 of rational numbers. It's page 201 out of our workbook. You know how we have some friends here this year from South Africa?
Yes, ma'am.
We have a couple students from South Africa.
Amazing voices.
Yes,
They really are.
It's fun to listen to them.
Their accents are
So, when they came to America, they had to deal with a lot of different changes, right? Language changes, culture changes, all sorts of changes. Well, one thing in particular that is different from where they live is the way that we measure things in the United States. We have a different measuring system. Ours is called standard, but everybody else uses a metric system. For instance, this is a standard yardstick, right?
Yes, ma'am.
This is a meter stick. This is standard measuring. This is metric measuring. Notice, they kind of look the same size, right?
Yes, ma'am.
But they are not. Okay, the yardstick is 3 feet exactly. A meter stick is 3 feet and 3 inches. But they don't even measure in feet, because feet is considered standard. They don't even know what feet means. They use a different terminology with metric system. Yes, sir?
But I'm just curious, wouldn't the laws be more big, like new laws would be more big than like meters and how they measure things?
Yeah, the laws that of the United States would be a lot more demanding than measuring
getting into legal
stuff.
trouble would be less worth it, than trying so hard to learn about a meter system.
Yeah, I agree. But in math class, it's probably, this is a big deal, right? So much. All right. So today we're going to look at the differences in measuring. Another difference that y'all probably already seen in science class is with temperature. There's 2 ways to measure temperature, right? What are the 2 ways?
Celsius and Fahrenheit.
Celsius and Fahrenheit. What do we measure temperature in?
Fahrenheit.
Fahrenheit. Right now my clock is reading 68 degrees Fahrenheit. On the back is a button to convert to Celsius. Is it going to be 68 degrees Celsius?
No.
No, it's different. So we're going to look at that. And we're also going to look at some measurements with recipes as well that are different, because they don't use a cup. They use some other terminology, and we're going to look at that. So, first, we are here. Obviously, this is not an accurate representation, because is that as long as this meter's ruler?
No.
No. But we're looking at the differences. And it's showing that 1 foot represents how much meters? Okay, I think that's your first blank in your table, right? 1 foot represents 0.3048 meters. So record that in your table. The next row in our table wants us to look for 1 what? 1 meter. So I need to make sure this meter reads a 1. Do you agree that that probably rounds to a 1 for meter, right? So what does 1 meter represent in feet? All right, let's record that in our table. You got a chance?
How would you actually find that without just using that?
We're gonna look at that in a second.
The
Yes.
first one, could you round it to 3.3?
I could, but I'm not right now. Okay, we need to look at a few more. So I'm gonna just concentrate on each meter. So I'm gonna scroll this to 2 and see how many feet are in 2 meters and how many.
6.5834.
All right, 6.5834. So what looks like's happening each time with the feet?
It's going up by 3 again.
It's going up by about 3. So for 3 meters, what could we predict?
It's gonna be
10.
It's gonna be about what?
9.
9, probably between 9 and 10, huh? So if I scroll to 3, 9.8751. Did it go up about 3?
Yes,
ma'am. Think we need a couple more measurements. What could we predict for 4? It's gonna be around around 12. Oh, it might. Well, I guess we could. 13 is around 12, huh?
Yes, ma'am.
So 13.1251. And what would we say 5 is?
Around 16.
Around 16.
Maybe 17.
16.4168. What was this one?
3.2917.
Okay, what's happening here is every time it's going up 3.2917. It adds about 3. It doubles this every time to get the next one, right? There was something we learned at the beginning of the year, started with a P, that this table represents.
Proportional.
It's proportional. Because what makes it proportional? It's all reduces down to that lowest number. I agree. What else makes it proportional, Chance?
They're all adding by the same exact number because that top number, like since you add it twice and that gives you 6.5834, and you add it that number times the 6.5834, and then you get the 9.8751.
Yep.
So they're proportional.
Very good. So right here where it says, what do you notice? What did we notice? It's proportional. Well, Chance asked a question a minute ago and he said, is there a way to figure this out for any amount? And we have an answer for that. Number 2 says, how many feet are in 6 meters? Well, I don't really know that right now, but I'm going to use what I do know. I know that piece of information. I know 1 foot represents how much meters?
0.3048.
Yeah, never mind.
Okay, represents that. That's what I know. Now I'm going to look at what I want to know. I want to know how many feet are in what?
6 meters.
6 meters. So I have a piece of information. Where am I plugging that piece of information in? Chance? Where am I plugging 6 meters in?
Oh, on the yeah, the top. No,
Oh, at the top, it's
The
feet.
bottom. The bottom.
Where is it talking about meters? The top or the bottom?
Bottom.
So 6 meters is plugged into the bottom here, and I want to know how many feet. Do I know how many feet right now?
no, ma'am.
So what can I put here? I need something.
Question mark. Or
Okay,
X.
but we're big kids now, so we put variables. Now let's kind of refresh our memory of how we solve problems like this. And Miss Adams created a silly method that works, and I called it a silly name. Anybody remember how to solve this? Alicia? Somewhat.
Oh.
High heel method. What do I circle for my high heel?
The 1 foot and 6.
I circle the 2 numbers across from each other.
You get 6 and then
What do I do with my here?
you divide.
I divide, which means that's the heel. So I'm going to multiply 1 times 6, and that gives me what? 6. Then I need to divide by 0.3048. Well, something like that, I'm not going to let you do by hand because that's a lot. So 6 divided by 0.3048, and I get x equals 19 point, let's round it to 2 decimal places, the hundredths. What?
It's 19.7085. Because if you just add that with the 3.2917, you get that.
I like Braden's reaction there.
Because it's so much easier because we also know like that like the 5 right here and then the number in
I want 2 decimal places. There's 2 right there. There's a 5 behind that. What does that 5 do?
make that 8 and 9.
Rounds the 8 to a 9, so I get 6, 9. Is this inches?
No ma'am.
What
It's
is it?
meters. No, it's feet.
What did X represent? Feet. This is 19.69 feet. So how much does 6 meters represent in feet?
19.69 feet.
Very good. Okay, we're going to flip over to number 3 now. And now we're going to look at the difference between Fahrenheit and Celsius. And right now it has the freezing point of water, which in Fahrenheit is how much? 32 degrees Fahrenheit. And what is it in Celsius? 0 degrees Fahrenheit. Okay? Well, we need to fill in the table here first. We want to first look at 1 degree what? Celsius, because there's a 1 on the Celsius. So I'm going to move this to a 1. And what degrees Fahrenheit do I have? 33. Now what do they want me to look at?
1 degree Fahrenheit.
1 degree Fahrenheit. So I'm going to grab Fahrenheit and look at a 1. Passed it up. Whoa. Oh my goodness. There. 1 is negative 17 degrees Celsius. Well, let's look at what. Okay, I want to look at, let's increase it by another degree Fahrenheit. So let's look at 2 degrees Fahrenheit. What do you think it's going to be?
Like,
Oh, 18. Negative 18.
Oh, it's going to get colder, even though the Fahrenheit's getting,
I mean, no, negative 16.
nah, tricked you up with those negatives. So here, I go,
oh wow.
and 2 degree Fahrenheit is negative 17. So what probably happened is that 1 degree Fahrenheit, it was probably like negative 16.8. What does that round to? Negative 17. And then 2 degrees Fahrenheit probably gave you like negative 17.1. What does that round to? Negative 17. So were they, if we looked real closely at it, were they exact same?
Not really.
If we rounded them, they
Yeah.
were, but if we didn't round them, they probably weren't. Well, let's look at 3 degrees. We think it's going to stay 17? Negative 17?
16.
Negative 16? Oh, that's 4. Negative 16. Alright, so 3 degrees is negative 16. What do you think 4 is going to be?
Negative 16.
Negative 16 again?
Yes, ma'am.
Looks like it was.
Last gonna be like negative 15.
If you notice, it's almost like 2 like halves.
Yeah, it's going by
You know how like you take like one half and the other half and make the whole? Well, this is kind of how it is since like 2 numbers are the same thing. So like 117 is the half the other 17 and then they move up.
Yeah, probably so. Looking at the decimals, yeah. So we need one more spot in our table, so we need to look at a 5. Ooh. And it went to a negative 15. Well, our last table, we called it proportional because it was increasing by the same number every time. Can we say that for this table?
No, I mean, kind of, because it's still going down, but it's not by every single time.
They're all disagreeing with you, sir. So if it's not proportional, how do I say that?
It's
It's not proportional. So on, what does it say? What do you notice? It's not proportional. While we're here, anyone know what the boiling point for Celsius is?
375.
Celsius?
No, that's Fahrenheit.
100.
No, like 80.
Celsius boiling point is 100. What is it Fahrenheit?
Negative 100.
What?
That's cold.
That's way down here, bro.
Bro, I don't know what Antarctica is living in.
Boiling point for Celsius is 100. What is it for Fahrenheit? 212 degrees. Well, freezing in Fahrenheit is obviously what?
33.
Hey, refocus.
33. In Fahrenheit.
Fahrenheit is,
32.
I don't know what woods you're sitting in that you're freezing in. I think it froze your brain.
No, because we were going
32 degrees Fahrenheit is freezing, which means in Celsius it is freezing at 0. Anybody know what the normal room temperature is?
No.
75.
65?
75.
Reading 68 in here on my clock.
What is your clock right
Is it like normal human body temperature, like 9?
We're looking at room right now. They said normal room temperature is 68 degrees Fahrenheit or 20. We're at normal temperature right now. What is the normal human body temperature?
Around 97.
Around 97?
I would say 95.
Nobody knows what your normal temperature should be?
95.
It's like
95.
It's like 98 because like when I took my temperature,
You got around 97, 98.
It is 98.7, but they say 99. What did they do?
Rounded it.
They rounded it. All right. So let's move to number 4. And number 4, these are 2 formulas that they figured out of how I can change from Celsius to Fahrenheit. Well, I have some letters in this formula. What do you think the F stands for? Fahrenheit, and the C stands for Celsius. So if this one says equals C, what is that going to give me an answer for? Celsius. And if this says equals F, that's giving me an answer for Fahrenheit. Well, in this problem, it says 80 degrees Fahrenheit is what degrees Celsius? So I need to figure out which formula I need to use. What is my final answer need to be in, Fahrenheit or Celsius? It says what in degrees Celsius. So what do I want my final answer to be in? Celsius. So which one of these formulas is going to have a final answer in Celsius?
I'm guessing the one
The
with the
first
C.
or the second?
I'm guessing
The first one. So I need to use the first formula for this problem because they gave me a Fahrenheit. So I'm using the first formula. You're writing this down because you're going to have some like this for homework. And I have a piece of information to plug in that they gave me. They gave me the Fahrenheit. And what was the Fahrenheit? 80. So where am I plugging the 80 in for?
For the F.
F. So 5/9, 80 minus 32. Now I can solve with order of operations. What should I do first? Parentheses. What is? Do I have work in my parentheses?
Yes, ma'am.
Yes. What is 80 minus 32?
48.
Wait.
40.
That's 50.
It's 58.
No,
It's
wait.
a number. I'm gonna work it out.
48.
It's 48.
Yeah, it's 48.
48 times 5/9. Where did I get that times from?
Because there's like nothing right there. It's like in the middle.
It's sitting next to a parenthesis, which means multiplication. So I have a fraction times a whole number. How do I multiply that?
Ooh, 5. Put the 48 over 1.
I put the 48 over 1, and I multiply straight across. So I do 5 times 48. I'm going to come over here. 5 times 8 is 40. 5 times 4 is 20. 240. Then 9 times 1 is
9.
9.
Simplify it.
We gotta do
Now I need to come over here and do some scratch work division. So 240. Can 9 go into 2?
2 times.
Can 9 go into 2?
Oh no.
Can 9 go into 24?
Yes, ma'am.
How many times?
2 times.
That gives me 18. 24 minus 18 is 6. Bring down my 0. 9 into 60?
6 times.
6 times. That gives me 54. I get another 6. Put a decimal. Bring down a 0. Oh, what's happening here?
It gonna repeat.
What's repeating?
6.
The 6. So this equals 26. Oh gosh, I messed that up. 26.6 repeating, but it says round to the nearest whole. Notice how I always go back to my directions to see what they want. That's something a lot of people forget, and they would type this in and submit the wrong answer. Nearest whole number. So what would this be rounded to?
27.
Let's see what Chance thinks. What would this be rounded to with his rounding? Oh, very good. It would be rounded to 27 inches?
Degrees Celsius.
Degrees Celsius. 27 degrees Celsius. Okay, let's look at number 5, and I want you to circle it. Number 5, circle it. The first two problems is talking about degrees, Fahrenheit, and Celsius, right?
Yes, ma'am.
Didn't we just do a problem like that?
Yes, ma'am.
So what example am I, problem number am I following for those two?
4.
Problem number 4. Okay? For these two problems, it's talking about meters to feet. We worked a problem earlier like that. What problem number is that like?
Problem 1.
2.
That was number 2. So problem 4 is going to help me with this. Problem 2 is helping me with that. And we're going to look at problem 6 together. What?
How would that help? I mean, I know it does help, but like, you wouldn't be able to get the other number.
Oh.
Where the Fahrenheit is.
Didn't they give me a different formula to use
Yes, ma'am.
at the top of that page?
Yes, ma'am.
They gave me 2 formulas. So I bet that helps. Think so? Okay. So let's look at number 6. Number 6, we're looking at baking and the difference between baking. And most people use the metric system, and we come up with U.S. customary units because we wanted to be different.
Special.
All Americans wanted to be different. Imagine that. Okay? We'll call them special. So they said 120 grams of flour equals 1 cup of flour. And then we need to fill out some more information. 160 grams of cornmeal. How much? That equals 1 something. Looking at my conversions up there, what does it equal?
Wait.
160 grams of cornmeal. What does it equal? 1. Here's where it's talking about cornmeal. 1 what?
1 cup.
Cup. That was easy. There was no work to do. I just used my brain. Then the next one says 50 grams of sugar equals an amount of cups. I need to see where it's talking sugar up here. It says 1 cup of sugar equals 200 grams. Did they give me 50 grams? So they gave me this information, and I need to find this. So I'm going to look at what I know. I know 1 cup represents how much?
200 grams.
200 grams. Stop the extra talking. You should be writing this somewhere. Now I'm going to look at what I need to know. I need to know what? 50 grams. Well, where am I going to put that? On the top or the bottom?
Bottom.
What told you the bottom?
Because
Because
they
that's
want to
where we're
get
putting
200
grams.
grams.
That's where the grams were on what I know. And what should I put up here in this empty space? An X, because I'm looking for that. So what 2 numbers need to be multiplied here?
50 times 1.
50 times 1, and what is that?
50.
And then I divide by,
200.
so I have 50 divided by 200, and I need to simplify that.
Yes, ma'am.
Did you know there's a zero cancellation trick?
Yes, ma'am.
You have a 0 on top and a 0 on bottom. You can cancel it out. So now I have 5 over 20. And can I simplify that?
No.
Yes.
Yes.
That's 4, isn't it?
Yes.
Oh, 1/4? Or 4?
1/4.
Why is it not 4?
Because 5 does not go into 4 times.
It's not improper. Thank you. So what can I divide both of these by? 5. And 5 divided by 5 is 1. 20 divided by 5 is
4.
So what is my fraction of cups I need? 1/4. Okay, let's keep looking here. Says 3 milliliters of salt equals 3/4 something. I don't see salt talked about here, but what does milliliters change to? Really?
ML.
ML is milliliters. What is it changing to?
Teaspoon.
It's changing to teaspoons. So looking at this, it's changing to teaspoons. So they did the math for me. So it's 3/4 what? Teaspoons. Then our friends from South Africa came over here and got a recipe, and they used to use 2 eggs for the recipe. Are they going to come to America and say, oh, I've got to use something different?
No.
Are they still going to use 2 eggs?
Yes.
So that's kind of silly, but some people might think that they have to change it to 1 egg.
I mean, 2 eggs isn't like a mushroom.
Eggs is everywhere. You either have an egg or you don't have an egg, right? Okay, then that was nice. They did milk for us. Now I need to look at vegetable oil, and it's measured in milliliters, and I need to know how many cups. Okay, what piece of information in my baking conversion is going to help me with that?
1 cup fluid ounces.
What is fluid ounces? What's fluid mean?
Liquid.
A liquid. Okay, so is vegetable oil a liquid?
Yes, ma'am.
Okay, so does it make sense that we're looking at milliliters of liquid here?
Yes,
It
ma'am.
does. So we're going to use that to help us. So I'm going to write that because that's what I know. 1 cup equals 240 milliliters. Now I can write what I need to know. What piece of information do I have?
60 milliliters of vegetable oil.
60 milliliters of vegetable oil. Top or bottom?
Bottom.
Bottom.
Where we're putting them.
Okay. And we'll put a variable there. So what 2 numbers are getting multiplied?
60 times 1.
60 times 1, and that is,
60.
then we divide by,
240.
so I have 60 divided by
So you cancel out the
240.
zeros. Cancel.
I can cancel out my zeros, a nice trick. I got 6 over 24. The answer is just 4.
No,
What
ma'am.
can I divide both of these by? 6. 6 divided by 6 is 1. 24 divided by 6? 4. So how much cup of vegetable oil do I need?
1/4 cup.
1/4 cup. All right. Then when they were in South Africa, they used to bake at 220 degrees Celsius. But now we measure in Fahrenheit, so they have to convert that. So I need to come back here's where we're answering Chance's question again. I have two formulas, right? What am I looking for? Celsius or Fahrenheit?
Fahrenheit.
I'm looking for Fahrenheit. So this time I'm using 9/5 C plus 32. So 9/5 C plus 32 gives me Fahrenheit. I need a piece of information to plug in. What can I plug in? 220. What letter do I plug in? Into C. So 9/5 times 220 plus 32. I'm going to erase this and write my work up here. So I have 9/5 times 220 plus 32. Order of operations, I multiplication and division first. But I don't want to get this into a decimal, so I'm going to multiply these two as fractions. So I need 220 times 9. 9 times 0, 0. Gives me 18. 18 plus 1 is 19. So I get 1980. 5 times 1? 5. I need to bring my plus 32 down. Now I need to divide by 5. Do you think that can divide by 5? What?
I made the 32. I made the. Never mind. I'll keep the 32.
I need to divide by 5. Can 5 go into 1?
No.
Can 5 go into 19? How many times? 3 gives me 15. What's 19 minus 15? 4. Bring down my 8. 5 into 48. How many times? 9. What is 9 times 5? 45. I got 3 left over. Bring down my 0. Can 9 go into 30? 6 times. 6 times 5 is 30. Anything left over? So 396. So this turns to 396 plus 32. Well, that turned out nice. Can I add 396 plus 32?
Yes, ma'am.
That's gonna give me 4 what? 28. 28 degrees Fahrenheit. So they used to cook it at 220. Now they cook it at 428. Huh? Okay, number 7 and 5. You're practicing for homework. Tomorrow I am checking last night's homework and then tonight's homework. Thanks for listening. Have a nice day. Peace out, home dogs.